Thanks a lot for your interest for this panel, which combine three main technologies: Internet of Things, 5G, and big and smart data. So I will start introducing the theme. I will present some of the issues that are of interest for all these three technologies. And then I will give the floor to our panelists that will present their views on the applications and technologies. And after their presentation, we will have a number of questions, and we will open the floor for discussions. And you can be involved as well in the panel. So our panelists today are Laurent Schmitt, Vice President of Strategy and Innovation from Alstom Grid France, Noza Boujama, Director of INRIA Research Center France, Ángel Hernández Bravo, Distinguished Chief Architect IBM Spain, and Daniel Pakery, Consulting and Sales Manager for Utilities Ericsson France. I will give the floor to them to introduce themselves, and then I will continue my presentation. So, Laurent, please.
Okay, so good afternoon, ladies and gentlemen. So my name is Laurent Schmitt. I'm in charge of strategy and innovation on Alstom Grid, and I'm going to introduce you a few of the challenges which we face in the energy vertical about introducing big data technology, as well as the challenges related to data acquisition, telecoms, and so on.
I'm Noza Boujama. I'm the director of a research center, INRIA, which is a governmental research center on computer science and math. We are about 500 people in this research center and 30 research groups. And I will talk about an application in the environmental domain for digital agronomy.
Hello, my name is Ángel Hernández. I am an advisor in the CTO office for Europe of IBM. I am a distinguished chief architect for IBM system in Spain, Portugal, Greece, and Israel. That is the business unit. And I will talk about technology around Internet of Things, and also a little bit of business model, because Internet of Things is not so a problem of technology. Perhaps the technology we need for Internet of Things is already developed or under development, but it's more important to find the right business model to develop Internet of Things.
Good afternoon. I'm Daniel Pakery. So I'm from Ericsson in France, and I'm responsible to develop the utilities business in France. So as you know, probably Ericsson is at the heart of this transformation based on connectivity, 5G, Internet of Things, and big data, of course. But these are the topics that we're going to elaborate upon during this panel. Thank you.
Okay, thanks to all of you. So we will start to introduce our topic, so the ecosystem for IoT. And you see that in this ecosystem, all these three main technologies are present. So network technology, it's at the core of communication for Internet of Things application. And data, it's at the center of exchange all this information, and as well create new services for the different applications. At the same time, Internet of Things becomes more and more interconnected with other platforms that are already available, and Internet of Things application and Internet of Things platforms are interlinked in the future applications. And this is valid for all the different verticals in which these applications are operating. At the same time, we are seeing that it's evolving a need for a common approach on architecture with different layers. And on these layers, we have the technology that we will discuss today clearly identify and having a clear role for the architecture view. If we are starting with applications, I will just have some snapshots. Wearables is one of the applications that Internet of Things is involved, and wearables will be the ones that will generate a lot of data, the one that will use smart data, the one that will be connected with other applications, the one that will use the network to connect with other wearables and to other devices in the Internet of Things applications. Then industrial internet with all the elements related to smart manufacturing will create a lot of data, will need a lot of smart data, and at the same time will need a different feature for the network connectivity and the requirements for network connectivity. If we are talking about combining vertical sectors, energy, transport, fleet operation, urban life, and this will be one of the topics that will be presented by one of the panelists, it's very important. So we will see that we will not have application dealing with only one sector, but more and more across the sectors. And interoperability for application across these sectors is essential. At the same time, the push for autonomous vehicle vision requires a lot of different technology and different requirements for this technology. Real time is different from real time in healthcare, real time in autonomous driving. And the amount of data generated or needed in such application is totally different. Another point, it's smart farming and food security. We will see, and will be presented by one of the panelists, an application related to smart farming, which becomes one of the emerging applications for IoT. Interestingly enough, we try to combine and play with words and say that IoT is about the 6 A's. So A's related to anything, anytime, any service, any path, any place, anytime. However, the big data is related to the 6 V's. Volume, value, variety, veracity, availability, and velocity. And this is an interesting play of words. And when we come to 5G, the G, it's already, the 5G, it's already inside the title of the technology, but the challenges are different. And we see that there are 8 other features that are very important in the development of 5G technology. All this brings a lot of challenges for IoT and smart data. The slide shows some of the keywords that we will address during the panel discussion. In this context, I want to introduce you as well the challenges that we face at the European level and how these are addressed today by the introduction of a new alliance, the Alliance for Internet of Things Innovation. So we see the Internet of Things is the next digital revolution. We see the combination and the convergence of different technology. We see the convergence of physical, digital, and cyber worlds. We see a combination of IoT, cloud computing, big data, real-time smart analytics. All these are very much related to what we will discuss during the panel presentations. However, we have some challenges, and the Commission decided that in this context, they launch a new alliance for Internet of Things innovation that contribute to large-scale pilots, to foster experimentation, replication, and deployment, and to support convergence and interoperability of IoT standards. At the same time, develop IoT ecosystems across vertical silos, including startups and SMEs, identify, communicate, and champion EU spearheads to speed up the take up of the IoT technology. Then gather evidence on market obstacles for IoT deployment in a digital single market context, and map and bridge global EU and member states IoT innovation activities. The Alliance is about vision, creativity, ideas, inspiration, cooperation, and solutions. The Alliance was launched in March 2015, and this is, in a way, a large initiative that is matching the 5G PPP, the Smart and Big Data PPP, with a lot of projects that will start in 2016, 2017. For 2016, it's expected that a budget of around 110 million euros will be available for implementation of these large-scale pilots. And to conclude, the Alliance will have 11 working groups that are addressing 4 of them horizontal issues like research, innovation ecosystems, standardization, policy issues, and 7 vertical working groups that will address the different industrial sectors that will be covered in the future IoT pilots. So with this, I will conclude the introduction of the panel, and I will invite Laurent to present his point of view about the topic, and then the other panelists will present their point of views. And at the end, we will have a number of questions, and we open the floor for discussions.
Okay. Thank you very much for that introduction. I'm going to speak during the next 10 minutes about how we see the telecoms and the IoT to start entering the energy vertical, or the energy and smart city vertical, as the one of supplier of software and hardware technology into that vertical. So for those who don't know Alstom, we are supplying various infrastructure in cities. Some of them are train, tramways, some others are power plants, wind farms, solar farms, and grids. And I myself belonging to the division which supply equipments to the grids. So these equipments are composed of heavy hardware equipment, plus also some activities supplying control centers to utilities for them being able to optimize operation of their grids. So these are composed of various sets of software on the back end to be able to operate the flows of energy into the grids, hardware equipment automation inside the energy hubs called substations inside the grids, and very high-speed embedded automation for converting AC to AC into the grid. So what we call IoT and big data into our smart grids energy space is basically the evolution of technologies required to optimize and control transmission and distribution grids. So first of all, a very important element to understand is that IoT and software and big data in a utility control center is not something new. It's to operate a transmission and high voltage grid, we already have a lot of technology. You see here a few examples of control center which were implemented as example in the US, where basically to operate a grid at the scale of a country like France, we kind of controls and operate SCADA up to, I would say, around about several hundreds of thousands of devices, and using various IP-based telecoms. And that's pretty much where we start from. So that has been the state of the art on the last 5-10 years. What we've seen recently is really a significant evolution of the way we operate these systems. So we do have several of demonstration innovation projects with some of utility customers. And we really see the scope of operating grids evolving towards only controlling substation and primary equipment, transformers, equipment in the grids into connecting with the consumer. And that's all in relation to the introduction of distributed renewable into the grid, so distributed PV. Energy is getting now produced at the level of the consumer. The consumer turn into a prosumer, producing energy into the energy grid. Pretty similar to what we saw in the internet, I think 5-10 years ago, where the more traditional content, with the more traditional content. Another element which is very important is because of this amount of renewable which comes, the intermittency and uncertainty of stability of grids in the electricity has increased, and there is more interest for grid operators to call for flexibility of consumer in them operating, I would say, in reaction to real-time price signals. So basically trying to find new model where the grid operator on the energy supply price signals for incentivizing various type of demands on the consumer side. And of course, what is really new is that it requires not only control on the energy grid side, but also interaction with IoT and with devices on the consumer premise. So that's really something which we have seen evolving very big time in the US, and we progressively start to see emerging in Europe as well. So that's the first very key element. Of course, associated to that comes the question of the business model and how would the consumer be interested to consume various kind of energy, various services of energy, for example, pure green energy, pure CO2-free energy. And that all goes into what is the indication which we need to supply to the consumer of energy for him to be able to take appropriate decision into his real-life operation. And that's what we've come more recently into this topic of smart city being a broad term, but we are really investigating the vertical of energy and transportation and trying to figure out what should be the data to be supplied to the consumer for him to take appropriate decision into his life. So I'm not going to spend much more time on the complexity of operating an energy grid. What I want to say here is really what is new into that environment is this connectivity to what we call distributed energy resources. So you see here a few examples, solar PV into the roof, electrical vehicle, storage. So I think that was quite new 3-4 years ago, up to a guy called Elon Musk came into that market and decided to really reinvent this model and just launched company on renewable called SolarCity in California. He launched Tesla in the EV, and as you probably followed, he's now launching storage into home for basically enabling to store electricity on the grid edge when the electricity price is low enough. So we really see an entire new gameplay into that industry where historically the utility were connecting with power plants and controlling power plants, where now utilities are monitoring power plants, checking when they produce, depending on sun, weather, and so on, and trying to influence consumer to use energy when the energy is cheap or green. So that's significantly changed the technology which is required on the back-end system, because obviously, as you can imagine, at the end of the day, there are operators having to take critical decisions against certain scenarios, extreme weather conditions, probably like today. Today is probably a very stressed environment in the energy grid, because this is probably unexpected heat pushing a lot of consumption now. And the question here is, what are the new technology to be embedded on the back end, on the big data analytics and software, to be able to bring appropriate decision on a mouse click of an operator, which stays, I would say, a single decision makers in case of a critical situation into that grid. So here comes a lot of challenge related to, I would say, standardizing that flow of data. I would say turning it into understandable data for the grid operator to take these decisions, and running models, forecast model of what's likely to come in the next few minutes, hours, and how close is the system to a blackout, and all these kind of conditions. Another element which is very new into that environment is the cybersecurity, because obviously to operate these grids, we now need to interact with much more devices into the homes, consumers, and so on. And of course, that increased the surface of attack potentially into the system. And obviously, hence comes the question, apart from the privacy of the data, which is primarily owned by the consumer, about the risk of being hacked through these new entry points. So a few examples of what has been done on big data analytics. So that's a project which we are currently working on, just to give you a view. That's with the EuCNC in the US. We are talking now about, on one hand, on the back end, getting access to around 20,000 employees to that real-time data through various of mobile devices and so on real time, and being able to spread that data across 15,000 square miles in the Carolinas and Midwest, and gather that data from various points of substation up to 1.1 million distribution transformer and 4 million consumer. So you talk here about potentially real-time information down to second information times 4 million customers times a very large number of users. So that's for sure pushes the size of this IT infrastructure much beyond what they were designed for at the beginning. Another element which we see a big time coming is this issue of estimating the aging of the assets and infrastructure. So that's another example of projects which we currently run in Middle East, in Qatar, where basically they are very conscious about making efficient upgrades of their distribution and transmission transformers. And they are now like spreading a really large size of real-time sensors into the transformers for projecting aging models of this transformer for operator to take suitable decisions. So here, of course, all the question is, what type of data do you need to get? What is the model you need to build? And what is the latency which you need to build out? And I'm not sure about how this connect with 5G and so on, not being from a telecom environment. But what is clear is we are a large telecom integrator as a supplier of this technology, and we are always very careful combining the best series of technology across I would say old GPRS to 2G, 3G, 4G, 5G, and new technology like LoRa. So I think that's really what is particular into that energy space. We are really talking about Internet of Things and not Internet of Humans, and things being very remote into the basement of buildings and into very remote areas. So typically are areas which are not always the best place for putting 5G antennas and so on. So there is always this question on how to collect that data. Another example of project which we are currently running with the transmission grid operator in France, RTE, that's exactly the same model, and we are rolling out sensors in that substation for having a better estimation and producing big data calculation on the aging of these hardware equipment, and in the same time bringing a new layer of cybersecurity into that critical substation area and better protecting the assets. As you probably all know, energy infrastructure are extremely critical into our economies, and these are always considered as operator of vital importance in most of these countries. Another example which I can run through very quickly, and again that's just a teaser for maybe further question after on technology and so on. That's a project which is currently running in New York, where we are trying to offset a congestion on the energy of the New York grid area on the energy side by adding basically demand response schemes into various type of consumer, into flats, buildings or residentials, and trying to manage congestion through better interaction with consumers. So here it's a lot about connecting thermostats into home, connecting plenty of sensors. And here we are just hitting the IoT domains of companies like Netatmo, Nest, and these guys coming through a different angle and bringing, I would say, data to consumer for the purpose of other services, but potentially bringing also data value to the energy environment. Last slide is another example of a project which we run in Nice, a very famous project called Nice Grid. And here what we are doing is working with the French distribution grid operator into trying to interconnect at the level of a city, which is the area of Carros, is in the city of Nice, trying to interconnect various buildings together and homes, and trying to build a mini marketplace for transacting energy peer-to-peer across these various consumers. So I think that what is very interesting on that project is, apart from the technological angle, is that there is a lot of thinking on what community should we create across consumers, who would be the early adopters of these services, and trying to think beyond the current business model of utilities in trying to bring a new utility business model related to energy storage, again demand response, or even smart charging of electrical cars. So in a nutshell and in conclusion, just because I'm probably in front of a telecom audience here, and I'm sure I'm probably, most of you are not specialized into that environment, and I apologize if I've been too much into the detail. What it ends up being from a telecom standpoint, and sorry to disappoint you here, it's not a 5G at all. And it's an infrastructure which needs to combine various layers of telecoms technology for several reasons. It's simply because there is a mixture of areas which are well and not well covered by wireless. So there is always a mixture of all power line carriers and wireless. There are lots of issues of various level of service level agreements and business models depending on the application and the apps which we bring into that. And last but not least, and I'm open for the debate on that, energy is one of these commodities which is extremely sensitive to resiliency. So what we talk about resiliency in the energy space is nothing to do with telecoms. I'm used to say that when I'm phoning in my car with my 4G, I'm at least getting lost 3 times on 60 kilometers. In an energy utility, you get lost a maximum 2 minutes a year. So I think what is very important is that there is an element of conservatism into that industry, which is also related to the, I would say, the importance of that resiliency aspect, which is a particularity of that environment. And that's why we still find GPRS, we still find extremely old technology to be combined into these environments. That's pretty much what I wanted to say. Very happy to interact with questions. If you have here my detailed contacts. I'm very active on Twitter, so feel free to connect there. Thank you.
Thanks, Laurent. Noza will introduce us in a totally different application environment. Please.
Thank you. Yes. So, as I was saying at the beginning, INRIA is a public research institute in France dealing with fundamental research, but very close to application domain with high impact and with social economic impact. So we developed several application domain from the big data point of view applied to energy, for instance, optimization of energy production distribution, but also machine learning, data viz, etc., etc. But I will not present the results of some activities in INRIA, Saclay Research Center, but my own research that I have started 3 years ago, and now we have results, interesting results. With regards to environmental challenge, in fact, I used to work on multimedia search engines, so big data issue and big data analytics is really my background, just to... our motivation for the project PlantNet that we have developed was about digital agronomy. As you know, climate change is today really, I mean, maybe today we can see the impact, but it's one of the biggest environmental challenge to agriculture, production, and food security, which is really a very challenging issue for the coming years. So today there is a dramatic increase of world population. What we need to notice is 1 billion with undernourishment, which is really a very big problem for the agronomy community. So we are facing two major threats. The first one is global food crisis, and the sixth extension, that means biodiversity erosion. So the accurate knowledge of plants is essential for sustainable agriculture and biodiversity conservation. The issue here is that botanical data are decentralized, heterogeneous, complex, completely unstructured tag that we are using, empirical measurements, but also sparse and incomplete, which is really, really difficult from the big data methods. As far as we have a huge and unknown number of species, but also the long tail distribution, that means, maybe I have the pointer here, yeah. For very few species, we have lots of data that allows us to make recognition and identification of species in good conditions. But for many, many and several other species, we have very few data, very few information. So it makes the objective very difficult to reach in terms of identification purposes. That means taking care of sparsity, and I will not go into details, technical details here, but the objective is really to increase and to, in fact, enhance this long tail distribution effect in this regard, and to have more observation for different species so that it facilitates identification. So what we have put forward is a collaborative information system platform based on multimedia crowdsourcing. So it's about multimedia information retrieval, identification tools, and mobile technology. So it's it's all about maybe, yeah, okay. What we have developed is mobile application that any user can take pictures on the fly, and then and it allows him to have the namespaces of these plants. So from the technological point of view, the challenges that we were, we were facing some challenges that I will present later on, but the opportunity, in fact, is that the images are now much more easy to acquire by anyone, which is not the case some years ago. At least in the biodiversity domain, it was fully non-digital content, which is a big concern for this biodiversity community. And also the visual content, in fact, is very informative for species characterization, which is also very useful. Mobile acquisition allows to aggregate a huge volume of simple data. I mean, this is really the opportunity that motivate us to develop such application, because now this mobile application allow us to go really make advances in identification. So for the bottlenecks that we have been facing is that I mean, it's very important to know that there is a shortage of botanists and taxonomists for several kind of species. There is no more expertise. So it's very important to have, in fact, have this know-how somehow into an autonomous participatory sensing platform based on such multimedia information retrieval technology within mobile platform. But also there is, as far as people, it's today easy to take a photo of species. So we have more and more accumulation of data, and there are some problems for data diffusion, basic data diffusion. So what we have put forward, in fact, in the early years is a web interface that allows us to have to work on few species in terms of leaves identification, and then it evolves to application which is available on Android and iPhone platforms, and handles about 4,000 species today, with multilingual, but also with handling user contribution, which is really the main interest here. So very quickly, the workflow, there are distributed persons, that's why we talk about crowdsourcing. There are multiple observations shared by different persons all over the world, and people are contributing. In fact, the database is updated in an incremental way, and in the same time there are a community of botanists. That's why we talk about collaborative validation and annotation. Once the database is enriched by observation, distributed observation, there is a community that allow the validation of content, and then it is then the database is upgraded and the contributions are collected all together and enrich this observation. And this long tail that we see at the very beginning is really, we are facing this long tail effect with user contribution. Today we have more than 750,000 downloads. During this month, it's about 33,000 users per day. We just updated the statistics during June this year, in 150 countries. This is also a layout of the users around the world since the starting of the application. We delivered the application on March 2013 till May 2015. These are the number. This is the number of sessions in France, but also in North America, which are the two main locations where this application is really very used. In terms of challenges for the convergence, in terms of the technology convergence, we are now discussing about different types of IoT installation. That means the application was developed at the early stages for mobile application, but also today we are discussing with a company about drone that will, in fact, use the same system that will have camera on board and with low observation, remote observation with visual observation of these kind of things to adapt the treatment, etc., etc. So today we will not have, I mean, the evolution of the work that we are conducting is the diversity of devices. So it's a concern, the heterogeneity of devices, to move forward in terms of our scientific and technological perspective, but also in the same time we are enlarging the crowdsourcing observation collections with the development of the network of observers, which is now really open to large public and not only to specialists. From the point of view, again, from the technology point of view, it's very clear for us that it's unprecedented knowledge will be derived from this collection. I mean, the distribution of devices that allow this wide collection of data, of visual data, which which are unstructured and very difficult to handle, but that's the V of, I mean, we have several V here on this slide. That means the variety, velocity, because we, in fact, maybe I didn't say that it's online and on the fly identification. So the real time is really a great concern, so that one of our major objective is the scalability. We have already somehow provide solution from the multimedia content point of view, but still today the velocity and dynamicity challenges are still open, as far as if we have several persons around the world that are contributing on the same data set, maybe on the same image, trying to make collaborative validation. So if we have to perform online machine learning, this will be really very demanding from the network point of view. And as I was saying, the major concern here is the heterogeneity and complexity challenges that that's why I was talking about distributed machine learning. This is very important, big challenge, maybe technical, but it is very demanding for the network community, in fact, point of view. So we need more and larger bandwidth for real-time inference, but also maybe my colleagues later will also in terms of infrastructure and optimization of the information between the network infrastructure should be really more consistent. So this is an application layer that will need, I mean, to perform better and to be deployed on several countries, and to have real-time collaborative framework with the different people. We need more and more effort from the network community. This is okay. Yeah, sorry. This was my last one. In fact, in terms of also it's a business model, there is another business model regarding such application, which is about weed identification. Also, a camera integrated within a robot. With the there is an SME who has this business model to make this evaluation of automated weed, which is very important because it causes 35% of damage, in fact, and having such identification on the fly through this kind of robot, it is really very important. Thank you.
So now we have a presentation from IBM, and Angel Hernandez will present the point of view of a technologist and a company that is very highly involved in IoT.
Okay. First of all, thank you very much to the conference for inviting IBM and myself. I have only a few minutes to talk about a very tough subject. Internet of Things can have a lot of issues that could be talked about, but I will talk a few ideas that perhaps some of you are not agree. So in the question you can ask me if you don't agree. It's perfectly, because this is more or less the point of views of a study of the IBM Academy of Technology, and it's our vision, but perhaps it's not the same than other ones. First, the potential of IoT technology is perhaps one of the biggest one in the history of computing. The challenge is to have access and make useful billions of sources for data, and to manage and transfer those data to be useful for the people, to make better the life of the people. All those data, all those information will be used in machine-to-machine interaction. Most of them will be machine-to-machine, so will be invisible to the people. This is one of the features of this new technology. Will be mostly invisible to the people, and some part, a minority, will be very interactive with the humans. So these are the two features of the Internet of Things. Most will be invisible, the most important, and the result will be very interactive to the people. First of all, we will talk about what are the technology challenges. As said in my introduction, we can say that most of the technology needed for Internet of Things are already available or is under development. Only a few things related with privacy and with security are not available in the way Internet of Things need to be developed. One of the technology changes are the sensors. Sensors are every year will become more and more powerful. The processor in the sensors or the device are more powerful every time, and so most of the computing could be put on the devices itself. So in order to have a scalable and usable Internet of Things, we need to think if the cloud computing model is enough or not, or if we need to distribute the computation, if we need to distribute the data, if we need to distribute the messaging and the controlling to the edge of the devices, giving what is named fog computing. That is something similar to the cloud computing, but distributed and decentralized. I have not much time to talk about fog computing, but it's an important point of Internet of Things in my point of view. IoT and mobile data. Now in the LTE traffic, most of the traffic is on Wi-Fi access nodes, and the question is if we multiply by 20 or 25 times the amount of data, if this will be possible to be feasible with the current technologies, or if 5G will solve this problem, or will need innovative hardware or software upon this technology. The IoT and big data is also a problem because the amount of data is a huge avalanche, and perhaps even the big data technologies, it won't be possible to manage all those data. The good news is that not all the data generated by devices or sensors is needed. Most of the cases, the only information that is useful for Internet of Things usability is the change in the state, not the overall data coming from the sensor. IoT and the data centers. Perhaps the data center in the future will need to change very much for Internet of Things because of the decentralization and the distributing of computing and storage. Perhaps the final picture is not the one at the left, but the one in the right. So the computing will be very near the devices, at least will be as a small data center, but in any case, we will have not a centralized view of the data center. Will be a fog data center, even no a cloud data center. The business challenges. A part of the technology changes that are important, there are a lot of challenges around the business because in order to a technology to be a success, we need that this will be profitable. This is something that is a must. A technology must be profitable to be a success. And we have several problems. The cost of connectivity, this is a fact that the connectivity is high. The cost of connectivity is high right now. 5G will change this in our vision. The challenge too is the internet after trust. The classical internet is a technology based on trust. I mean that all the interaction, the transaction on top of internet need to be trust the end nodes that are making the transaction. And this happens for make a Google search or make a payment with PayPal or anything else. But in a massive Internet of Things and with no a central authority, we need, in order to be scalable, an Internet that don't need trust. I mean trustless. I will explain after that what means trustless. I mean that the no interaction need to have another mechanism to have trust that is not a centralized authority trust. Another challenge is the lack of functional value. Most of the things that will be connected have been working with no connection for years. A toaster, for example, can be connected and this not make the toast better. No? What happened for a lot of things to be connected, what make something that is better than before? Is a good question. And the last challenge is the broken business model. One trend that we have in the Internet of Things is to have the same business model that we have, for example, in Google or Facebook on social network, and perhaps it's not the same business model. Standardization. There are a lot of standardization. I don't have time to make any detailed description, but we need standardization because the ecosystem, you can see the ecosystem is a mess. Is a lot of companies, a lot of institutions. It's difficult, and we need to standardization. If we have a look to the past, to the technology in the past, we can see that in the first steps of the life cycle of the technologies, we had a lot of standards, and with the maturity process, the number of standards became only a few. So perhaps in a couple of years we will have a smaller number of key standards that will be the good ones. Well, we can see the ones generated by IEEE or W3C. Also, the ISO 20248 is very important for standardization. Technology convergence. The key point in our view is the decentralization of the IoT. And one important thing is that the Internet of Things remains transactional. Perhaps are not the transaction related with a home banking transaction, but everything we made is a transaction. And adopting a peer-to-peer computing to process the hundreds of billions of IoT transactions will reduce the cost. That was one of the important things. In the absence of a centralized server brokering, we need to provide different model for file storage, for transfer, for authentication, for authorization, for control access. So we need another protocols, another mechanism. One of them, for example, in order to provide a device coordination without a central control point is, for example, the blockchain protocol. Blockchain protocol is an example, is the system that Bitcoin use in order to provide trust between two nodes of a transaction of Bitcoin. Perhaps a similar protocol will be used in coordinating and generating trust between two devices in the future. Innovation trends. There are different innovation trends. One of them is cognitive IoT application. Cognitive is something similar to artificial intelligence. The idea is to make the system to have a behavior similar to the human thinking. For example, the example that Ovidiu put in the first slides about car vision, automatic car vision, is something that should be simulated by a processor able to think as a human, but being a machine. And this is a challenge that will be developed right now. And another trend is the democratizing digital world, in the sense of, I said before, the fog and edge computing instead of cloud computing. Business model, and I am finishing. I have a pessimistic talking, that is, if we talk about business model related with having the capability to make business with the data, making advertising of marketing, that is selling the data to the people, and the marginal cost of this business model is zero. So we cannot go in that way as Google or these companies made. We need to think in other business model as, for example, the one liquefying the physical world. I mean, we need to make in Internet of Things the same thing that Spotify made with music or YouTube made with video. That is, make a granular access to the music in the digital world or to the video. And we need, with Internet of Things, do the same thing with the devices. And this is all my presentation. Thank you very much.
Angel. So now we have the last presentation.
Yes. Hello again. So I will try to be quick because otherwise we'll not have so much time to have a discussion around here. So my presentation will be about IoT, 5G, and a little bit about big data. So I guess most of you know who Ericsson is. So we are a leading telecom vendor, and we've been in this business for decades. But now also What is maybe less known is that we also becoming a full ICT company, meaning that we're combining IT and telecom expertise to bring solutions not only to the telecom operators, but also in other industries such as utilities and transport. So I will start by showing you quickly the connectivity history. So it took more than 100 years to connect places with the fixed phone, and it took like 20 years to connect people, and then it's going to be even more quicker to connect those tens of billions of devices that will probably be in the field in year 2020 and after. Talking about the Internet of Things, so what we see is that there will be two different types of connections in the networks. The first one on the left-hand side of the slide shows what we call the massive machine type communication, which is basically devices, objects that do not have very stringent requirements on the networks, meaning they need low bandwidth, they need not so high availability and this kind of thing. So it could be use cases like building management, vessel management, this kind of applications. And then on the other side, there will be another type of objects that will be much more stringent on the networks, that will require low latency and very high availability. And this will be for critical applications such as the grid control, such as the road traffic control, and this kind of applications. So that's why we at Ericsson, we introduced this concept of telecom-grade IoT and machine-to-machine networks, because we believe that what we have been deploying and installing for our customers in the telecom space will definitely be of great benefit also in this domain. In terms of the different connectivity technologies that are available or will be available on the markets, so there will be a need for short-range connectivity, so the likes such as Zigbee or Bluetooth. Now we start to see new technologies allowing long-range communications, but long-range with not so high bandwidth. And then talking about the 3GPP standards, which is behind 2G, 3G, 4G, and soon 5G. So what we can see, what we are working on is an evolution of those technologies towards the connectivity of machine-to-machine type and Internet of Things type. So, and those evolutions are related to, of course, the reduction of the device cost, because, of course, it's an important element when you need to deploy hundreds of thousands of devices in the field. It's about improving the coverage, I mean, extending the coverage of the cells in the networks, and of course, one very important element as well is the battery life. So it's implementing new power-saving features in the networks. So the topic of this panel is about 5G, but what I wanted to convey to you is also that already 4G and LTE is already evolving towards a machine-type communication. So here you can see the different steps and the different evolutions of LTE. So 5G, it's a lot about increased bandwidth, lower latency, many more connected devices, and all that stuff. But what is really important to understand also is that 5G will bring the flexibility and to be able to manage at the same time very different use cases like what I mentioned previously, like devices with very low latency requirements, low bandwidth, and then on the other side, at the same time, managing, for example, smartphone users and using a lot of video on their smartphones. So all of this will be able with the 5G technologies. Talking about the evolution towards 5G, so it's not there yet. It's going to be soon here. But I just wanted to share with you that we are already testing some of the technologies that will allow, for example, in this case, to higher bandwidth in the network. One other important elements when we talk about IoT and connectivity is what is happening on top of this. And because when you deploy a lot of devices in the field, one of the issues you will have to address is how you manage those devices in the field. Not only supervising those devices, maintaining and upgrading those devices. So, and in our view, it's really important to implement this kind of architecture as a layered architecture. So with different layers managing the different issues. So basically, at the bottom, you will have the device, then the networks, and then you will have in dark blue what we call the connectivity management layer, which is the way to make an abstraction to the upper layer about how you connect to the different devices in the field. It could be whatever kind of technology actually that can be used. And then the block in green is what we call the service enablement layer, which is basically the layer that all the applications and the business applications we believe should be built upon. Because at the moment, there are a lot of IoT and machine-to-machine applications already being developed, but most of them are being developed in a vertical way, meaning that an application is designed and developed to use specific objects only, and if you make another applications besides that use more or less the same object, you will have to redevelop all the layers within the application. So with this architecture, it will be much easier to implement different applications, even for different industries. So here, for example, we have just highlighted the transport industries, the energy utilities industry, and etc. that could be built upon those common layers. So here's a little bit more about what this service enablement layer can do. So basically it's about sending, collecting and transforming the data, and storing and transforming the data to be forwarded either to the devices or to the applications. There is, in this layer, we think that we should also take care about the what we call big data or data analytics, because of course, I mean, there will be a lot of objects in the field, so it makes a lot of sense to gather all the data coming from those devices and then transforming those data and then extracting the real value of the data at this level, at this layer, and then sending to the upper layer and to the applications only the relevant data for the different types of applications. I will just finish by what was presented in the Mobile World Congress this year by Ericsson. And because it illustrates also one concept that we believe is linked to this IoT connectivity and big data is the cloud, because we believe also that the IoT will go in the cloud, and all the businesses more or less will go in the cloud. So, about the transport and the road traffic challenges. So, of course, it's safety. So, we want to have less accidents. It's efficiency. So, we want to have less congestion and less traffic jams on the roads. And, of course, is sustainability. So, all of this can be greatly supported by IoT and the cloud. We have implemented for one car manufacturer what we call the connected vehicle cloud, which is the connectivity and the management of the connectivity to the cars sold by this manufacturer. And then from this cloud, and of course, I mean, the car manufacturers, they need to have a global coverage. So it makes for them a lot of sense to have their solution in the cloud, because then they can have a global connectivity, and then, I mean, they can offer the same service wherever in the world. So an extension of this connected vehicle cloud is what was presented in Barcelona this year. And it's what we call the connected traffic cloud. So it's an extension, means that by putting sensors and captors on the roads, on the signs, everywhere on the road infrastructure, and then making a connection and a communication between those and the vehicles using the roads via this cloud, then it can allow a lot of new applications and new use cases, like better safety and less congestion. And that's it.
Thanks a lot. So now we will proceed with the number of questions, and we invite the audience to participate as well. So we will start to consider first adaptability and scalability. And I will ask the panelists to try to answer to the question of how the IoT, 5G, and smart data or big data will influence the choices in the different organizations, what will be the roles of the platforms, and how this scalability will be implemented. Because now we are talking about 3 totally different technologies, and combining them will bring as well an extra challenge. So I will start with you, Laurent.
Okay, so what I can say for the energy space, I think we are in a particular environment because first of all, the energy system is a rather structured environment, so the data is rather structured. It's about collecting further data, further sensors, but there is an existing set of standards. The European Commission has done a lot of work under the Smart Grid Task Force for unifying standards with the association ETSIS and Senelec. And we see this being a very important foundation for scalability. That's an important element. What we also see with the growth of this new architecture is a change in the way to design systems. So these systems tend to be hybrid clouds, on-premise and in the cloud, and depending on the business application which you are considering, some are considered as extremely sensitive, critical, and has to be secured and do not go in the private cloud area and stay on premise. Some others are actually sharing data from the private cloud. So we really see on the energy space combination of data from Google Map into a control center of utilities. And so there is more and more business model around systems of systems, and we see this architecture evolving from approach of integrating data into a single system towards more and more API and a new business model around the sharing of data across subsystems of systems. So that's really the new trends which we see evolving. But again, when it comes to standard, our field is already very, very strongly standardized, and I think the next steps are pretty well defined now.
Thanks a lot, Laurent. So now I will ask Daniel on the other side, what are the roles of the platforms? Because now we will see that we will have the emergence of platforms for IoT, we'll have emergence of platforms for cloud. The telecom operators are building their own platforms. How you deal with these platforms, and how will be the future of the platforms for such application in the future?
Well, I guess I touched upon this topic during my presentation. I would say that actually everything is, well, when I say everything, I'm a little bit exaggerating, but everything is going to be virtualized. I mean, the networks are going to be virtualized, the network functionalities are going virtualized, and then the applications, I mean, the IT infrastructure is already virtualized, and then the applications in the end will be virtual. So it's really important to have this platform concept, trying to aggregate all the different needs into one single concept, because then it's much easier to be able to deploy new services or evolve the existing services.
Thanks, Daniel. So now we open the floor for you for one or two questions related to the topic, and then we move on to the next question for the other two panelists.
Thank you, Mr. Chairman. It's actually a request to the venue management. Is it not possible to dim these lights? It's no air conditioning, it just makes it that much worse. So please, through you, if possible.
Should be
to dim the lights a bit, it might reduce the heating here.
Application like for future IoT, so I can only move my hand and then the light dimming its control. So actually this could happen in the near future. I saw an application for a sensor, a brushless, that you place it on your hand, and using the movement of your hand, you can control drones or you can control different devices. So we are not there yet, but this is part of the future development for IoT. And I hope the organizers have received the request and they can dim the lights in such a way that we have a little bit less temperature in the room. Okay, another question?
Yeah, it's Alex Callis from University College London. The time is nearly done, therefore I would like to ask a question. Is it serious convergence of technology or is divergence of technology? I cannot see any convergence here. Contrary, I see the scale is very small in IoT because there are very few application silos. Although there are many IoT items, but the applications viable are extremely low compared with the internet application. On the other hand, in big data, there is only one platform and algorithms. There is not even applications with a space of substance. So suddenly it's more an integration problem. Is that what you are aiming at? Or maybe it's a time to leave the whole situation to evolve and be mature, and then talk about convergence. And convergence means, in my view, a better integration of the internet. Currently, it's marginal.
Thanks, Alex. So this is a question for Angel, because he presented the two views, and now we would like to hear the optimistic view on this question.
Yeah. Well, I try to answer the question. Yes, it's true that there are no many application, many apps in the market, and this is because one of the features of Internet of Things that make most of the operation, most of the computing inside Internet of Things invisible, because are machine-to-machine automatic interaction. And but there are also room for application because, for example, application related with cognitive analytics, with system of things, as the automatic car vision or that kind of thing is very interactive. So the interaction with humans has application, and also in the future. Most of the application will be related with one of the silos related with application, that is the physical asset availability. I mean, one of the when I talk about Spotify, that you has the music available in the internet. In the Internet of Things, we will have an application where you will see all the devices or all the physical devices that you will have available in time, or in a place, or in a region, a country, or for a special need in order to cover. And the application to do that will be developed as apps. Yeah. I don't know if I misunderstand your question.
Thanks.
Or not.
I think it's the first step, but the answer maybe we will have in few years when we will see the emergence of new applications. And this is what we are expecting. 2020, exactly like for 5G, we are expecting the first few full IoT applications. Now I'm moving on to the next question for the... yes, please.
I would like to add a comment to your question in terms of is it convergent or divergent. What I would like to say is that there are two enablers for the convergence between big data and IoT, which are not technological issues. It's mainly about business models, but also about property, responsibility, and liability. So, I mean, there are many applications where there is data traffic, but the deployment and of such application is somehow there is problems for large deployment due to whether to business model or to responsibility. If we think about connected cars, for instance, and machine to machines in this context, it's I mean, who is responsible of what? I mean, it's not yet deployed also because such questions are not fully solved, but also who belongs to whom, and how to monetize the data. These are bottlenecks for the convergence from my point of view. It's not only technological. This is my comment.
But then stay on this issue, because I want to ask you the next question about flexibility, because this is related. How you see flexibility, how you see heterogeneity and interoperability combined?
Yes. Also, one of the great concern from my point of view, it's, I mean, when we talk about flexibility, it's, I mean, less, from my point of view, of course, less a matter of standards, but more about interoperability. Of course, this is a point of view from data analytics, as far as we share unstructured data, to have a flexible platforms and a flexible workflow for, I mean, our objectives. It's really important to consider interoperable data, interoperable workflow, rather than try to standardize several of these items, which, from my point of view, seems to be very difficult.
Okay, thanks a lot. And then I move the microphone to Laurent, which is coming from a conservative industry. And then let's see how flexibility can apply to such an industry that has to open for cooperation with other verticals, and how this can be implemented.
So I think the complexity is in this utility industry on the conservatism is on one hand on the technical aspect of resiliency, and what is the threat of opening up. the architecture, especially related to security, as an example. That's one element. The second element is what is the business model to be created at each of these new interfaces? Is the Nest going to supply data to the utility, and what's going to be the model behind that one? And I think our utility industry is not used to these new models as compared if you go to the IoT and the wearable IoT. I'm wearing a watch here where I can control my house from the watch, and I see that it's going through 3 or 4 clouds, and there are definitely agreements between these clouds to share data, and I think that's a concept which needs to come to into the business model of this utility side. So I think that's an element. I think we should also not forget that the grid utility is a very large system, very synchronized system. So when you roll out, and we see it right now with the smart metering, which is seen as maybe an old device from an IoT point of view, but it's very hard to take the decision of rolling it out because you immediately roll it out over several millions of devices and so on. So that's also the structure of our industry, is we need to make sure the business model is there when you start to roll it out. So that's why it's also an industry which is not necessarily the most fast moving into these new domains as compared to the traditional IT industry. But I think what we see, as what I showed in my slide, that's definitely moving right now.
Exactly, and when we are talking as well electromobility, then you are talking about traffic management and the combination with the other
charging points in relation to traffic and all that kind of things.
Thanks a lot. So then I will move to Angel and Daniel for the next point, which is end-to-end security, data control and access, and X by design reference model. And when I say X, it's privacy by design or security by design. And you are providing platforms, you are working with your customers. What is your approach and what is your opinion? What will be the trends and which one will be maybe a success solution?
Okay, shortly. Our position is that with 100 billion of devices or several hundred billion of devices, the model for security, privacy, trust will be different for sure, because the current approaches to do that probably won't be able to manage a network of 100 or several hundred billion of devices. So, for example, the traditional security model of security by obscurity, that is the traditional model, that is make a closed system that is not able to be attacked by nobody, is probably not the model for the Internet of Things, and will be an open model where you will move on a network with secure nodes and also not secure nodes, promiscuous nodes. This will be a security model that will be managed interaction with nodes that won't be secure, and the model will need to manage this. And also in the kind of the privacy. What I said in my presentation is that the trust and the protection of the data and the integrity of the data need to generate encryption and certificates, not with a centralized authority, because this won't be scalable for the number of devices we will have. So we need mechanisms as I mentioned, the blockchain protocols and that kind of things, in order to allow secure transaction without having a central authority.
Thanks. So Daniel, in your presentation, you had as well the different layers. Security, I guess it's a vertical one. How you will address in the future?
Well, in terms of security, I think that we have all the needed technologies and methodology to address this. One thing that needs to be really taken into account is the cost of it, because you were mentioning by design. So by design, each new application, each new system will have to have security built in, and it's not a, I mean, it's a substantial cost. So this is one thing that has to be taken into account. The second comment I would make is that there will be different levels of security depending on the applications, the objects, and the users. Because what we can see is that most of the time, whatever the security measures you put on the systems, it's always faced by the human factors.
Okay, thanks a lot. So the last two points are related to maintenance and updates and share standards and infrastructure. And here I'll let the floor open, and I let the panelists to decide on which of these questions they want to answer. Because as we discuss the challenges in the future is when you deploy the devices, the lifetime maybe will be more than 3 years, will be 4 or 5 years. And then the upgrades, the maintenance, it's a challenge, will be a challenge, and when you have a combination of such 3 different technologies, it's important to address this issue. So the question is for all 4 of you, so please.
Yeah, I think on the utility side, we probably can learn from the other domains on how to do better maintenance, provisioning of devices, and updating of firmware and all that kind of things. I think that's historically that this is a domain where we have done a lot of engineering, which is hands-based engineering, and I think if we want to build the right business case and bring the savings, we definitely need to improve the plug-and-play aspect of the infrastructure, and I think that can unlock value into some of these business models. So that's something which we need to do some work on in the next few years.
Thanks a lot. Angel?
Yeah, related with standard, we need for sure a global standard and open standard, and also open platforms that allows to the developers to develop application or develop algorithms and protocols for Internet of Things. And for example, I think in Europe, for example, the FireWare platform, that is an open platform approach, is a good way of do things. There is another open platform, but for sure, if we won't have an open platform, won't be possible to develop something interoperable and something standards. And without the standardization, it's not Internet of Things.
Yes, if I can add something on the maintenance and upgrade aspects. When I was talking about the different communication technologies to reach the objects and the devices in a field, this is one aspect that needs to be taken into account. I mean, in terms of what are the capabilities of this network technology to be able to address those requirements. Because, for example, if you take the example of upgrading a firmware in the field, in the devices, so probably you would like to make it on a kind of broadcast basis, so that you just send one command and then all the devices in a certain region or whatever is upgraded. So and this feature has to be supported by the network technology. And also the bandwidth, because some applications may require a very low bandwidth, but again, if we want to upgrade a firmware, which is a few 10 of kilobytes, then again, I mean, if you have to wait like one day to have the firmware upgraded, I mean, it's not going to work.
So then one last chance for the audience to ask a question or two to the panelists. So this means that the presentation was were very clear. So then we thank to all the panelists for their contribution. We thank to you for participating in the panel and combining the pleasure of having a sauna and listening to a presentation. And we hope that we will see in the next few years the true convergence of these three technologies in applications that we didn't think about today. Thanks a lot.